In the heart of every galaxy, including our own, lies a secret, a point of impossible physics, a place where the laws of our universe are crushed into nothing. It is a monster that feeds on starlight, a cosmic predator so powerful, so absolute, that it captures the fastest thing in the universe and never lets it go. It is a one-way door in space-time. They are not just holes. They are the ultimate destination, the absolute end of space and time. They are black holes. In the cosmos, gravity is the master architect. It dictates the orbits of planets and bends the paths of wandering comets. To break free from a planet's powerful grasp, a spacecraft must achieve an incredible speed. This is known as escape velocity. The more massive and compact an object is, the higher its escape velocity. Now, imagine what happens at the end of a massive star's life. Its core, containing the mass of several suns, collapses in on itself in a fraction of a second. The result is an object with an almost unimaginable density. This catastrophic collapse creates an object so dense, it doesn't just bend space-time, it creates violent ripples, gravitational waves, that travel across the very fabric of reality. This stunning NASA simulation shows exactly that. The colored fields represent the curvature of space-time itself. The escape velocity becomes greater than the fastest thing in the universe, light. And that is the essence of a black hole. Surrounding this object is the event horizon. This isn't a physical surface. It is an invisible boundary, a one-way door. Anything that crosses the event horizon is lost forever. It is the point of no return. At the very center lies the singularity, a point of infinite density where all the mass is crushed. So, a black hole is not an empty hole, but an incredible amount of matter packed into an impossibly small space. But if these cosmic monsters are born from matter, specifically from dying stars, how does this cataclysmic birth unfold? Black holes aren't born from nothing. They're the ultimate remnants of the universe's most colossal stars. For most of their lives, stars are in a delicate balance. The outward pressure from their nuclear fusion battles the inward pull of their own immense gravity. But when a star at least 8 times the mass of our Sun runs out of nuclear fuel, this balance shatters. The core can no longer support itself, and gravity wins. In a catastrophic fraction of a second, the core collapses inwards, creating an unimaginable shockwave that blasts the outer layers of the star into space in a spectacular supernova explosion. What remains after this cosmic firework is crucial. If the remnant core is still massive enough, typically 3 times the mass of our Sun or more, gravity continues its relentless squeeze. It collapses past the point of a neutron star, past anything we can comprehend, into an infinitely dense singularity. A stellar mass black hole is born. But stellar mass black holes are just the beginning of the story. Lurking at the heart of almost every galaxy are the true titans. Supermassive black holes, millions to billions of times the mass of our Sun. Their origins are a profound cosmic mystery, but scientists believe they grow through 2 spectacular pathways. The first pathway is through relentless consumption. In the early, dense universe, vast clouds of gas and dust could collapse directly under their own gravity, forming a massive black hole seed. As you see in this simulation, this seed then begins to feed. It pulls in surrounding gas and dust in a process called accretion, consuming the equivalent of thousands of stars over millions of years. It is a cosmic feast on a galactic scale, allowing the black hole to grow steadily into a behemoth. The second, more violent pathway is through mergers. When galaxies collide, their central supermassive black holes are drawn towards each other by gravity. They begin a dramatic orbital dance, spiraling closer and closer over millions of years. As this simulation shows, they eventually merge in a cataclysmic event, releasing more energy in a single moment than all the stars in the universe combined in the form of gravitational waves. The result is a single, even more massive black hole. So, whether born from the death of a single star or growing into colossal giants through feeding and mergers, black holes are an integral and often violent part of the cosmic tapestry. But if they're invisible, how do we know they are even there? Black holes are, by definition, invisible. They swallow light, leaving only a void. So, how do we hunt for a monster that hides in the dark? We don't look for the black hole itself. We look for the chaos and the clues it leaves in its wake. The most spectacular clue is the accretion disk. When gas, dust, or even an unfortunate star gets too close, it doesn't fall straight in. Instead, it's captured by the black hole's immense gravity and begins to spiral inwards, forming a flat, spinning disk of superheated material. The friction and speed in this disk are so extreme that it heats up to millions of degrees, glowing brighter than entire galaxies and blasting out intense X-rays. We can't see the black hole, but we can see the brilliant, fiery death scream of the matter it consumes. Another way we find them is by seeing their effect on light itself. As predicted by Einstein, the immense gravity of a black hole warps the fabric of space-time around it. When light from a distant star or galaxy passes through this warped space, its path is bent, much like a lens. This phenomenon, called gravitational lensing, creates distorted, magnified, and sometimes multiple images of the objects behind it. We detect the black hole by the way it invisibly manipulates the light of the universe. And sometimes we find them by watching the stars, or rather, by watching the elusive activity around them. This stunning time-lapse from NASA's James Webb Space Telescope shows observations of Sagittarius A*, the supermassive black hole at the center of our own Milky Way. Webb detected faint flickers and brighter flares originating from its accretion disk. This invisible behemoth influences stars for light years around, and its activity, though subtle from this distance, provides irrefutable proof of its powerful, invisible presence. Through these cosmic clues, we can map the locations of these invisible giants. But knowing where they're only leads to a more terrifying question. What happens if you fall in? The journey begins not with a sudden plunge, but with a deceptive calm. As you approach the invisible border known as the event horizon, the universe around you begins to warp. Light from distant stars bends and twists, creating a surreal, distorted panorama. Here, gravity's grip on time itself becomes absolute. To a distant observer, your fall would appear to slow down, stretching over an infinite amount of time, until you are frozen as a faint image at the edge of the abyss, forever. But for you, the journey has just begun. You feel nothing unusual as you drift silently across the threshold, the point of no return. You are now inside the black hole. The laws of physics, as you knew them, are rewritten. There is no turning back. Every possible path, every direction, now leads to one inevitable destination, the center. Looking back, the entire universe, every star, every galaxy, is now compressed into a single brilliant point of light. You are completely and eternally cut off from everything that ever was. The journey towards the center is swift. And here, you face the black hole's most terrifying force. The gravity at your feet is now so much stronger than the gravity at your head that you begin to stretch. This extreme tidal force pulls you apart, atom by atom, stretching your very being into a thin stream of plasma in a horrifying process scientists grimly call spaghettification. Your final destination is the singularity, a point of infinite density where space and time cease to exist. What lies there is the greatest mystery of all. An end or a new beginning? Is the final, ultimate secret forever hidden from our view? From the fiery death of colossal stars to the silent, invisible giants ruling the hearts of galaxies, black holes represent the ultimate extreme of our universe. They're the final stop for matter, the end of space and time as we know it. To truly comprehend their cosmic dominance, we must grasp their scale. From stellar mass black holes, barely the size of a city, to supermassive giants at the heart of galaxies, larger than entire solar systems. These are the true titans shaping the universe. Their sheer size and immense gravity are a testament to the unimaginable forces at play. These cosmic behemoths are not just agents of destruction. Their immense gravity governs the motion of stars, and the powerful jets they emit can trigger bursts of new star formation or clear out gas to halt it. They are both the architects and the regulators, the creators and the destroyers, in a delicate cosmic balance. They are a reminder that in our universe, the most violent ends often lead to the most profound new beginnings, and that even in the deepest, darkest corners of the cosmos, there is an order, a purpose, a story waiting to be told.